Hello and welcome. My name is John Hyatt and I am an Automation Solutions Specialist at Broadcom. Today, I would like to introduce you to one of the features within Broadcom's Automation Analytics and Intelligence solution, SLA simulation for AutoSys workload automation. This session will be broken into 4 topics. In the first, I'll begin by providing an overview of AAI's simulation feature. I'll then talk about what is required in order for AAI to run AutoSys simulations. Following this, I'll provide an example use case containing AutoSys job definition changes, and finally, I will demonstrate what happens when this use case is executed in AAI. So what does the simulation feature of AAI provide? Well, what happens when changes are made to objects in AutoSys? Perhaps job schedules are changed. Perhaps job dependencies are altered. Maybe jobs will run for longer or for shorter periods of time. Any of these changes, combined or in isolation, could have disastrous impact to business-critical processes and SLAs. AAI can help prevent this. When executing a simulation, AAI provides a visual representation of its updated SLA prediction. This will show how the proposed AutoSys change or changes will impact SLA delivery, helping the business to understand the impacts ahead of time before any AutoSys changes have been made. This means that the business can gain valuable insight of their change impact and in doing so, reduce the risk of production SLA breaches and improve release confidence. In order to use the simulation feature, there is really only one requirement, that the AutoSys scheduler has been defined within AAI using the next generation prediction model. Selecting the prediction model for the AutoSys instance is only possible when its definition is first added to AAI. The selected prediction model cannot be changed or seen in AAI afterwards. However, if you have AutoSys schedulers already defined, then you can check the scheduler type within the Systems tab of the web UI. If the scheduler has been defined using the next generation prediction model, then the scheduler type will be defined as AutoSys v2. If your scheduler is not defined as v2 and you wish to use simulation, then do not fear. You can simply add the same AutoSys scheduler with the next generation prediction model alongside the existing one. If in the future you wish to consolidate onto the v2 scheduler and migrate your job streams across, then you can do this really easily by using AAI's import and export utility. Performing a search for the word export in our technical documentation will return the information that you need to do this. Let's take a look at a use case from a fictional customer. In this example, an application team are planning to make a small change to their AutoSys jobs. The first change is the addition of a new job to an existing box. The application team have remembered that when AAI is used to simulate a new job, an average duration value for its execution is needed. The second change was made necessary by the first. The new job needs to be factored into the application and therefore existing job dependencies need to be updated. The third update is not definitional. The team has also been made aware of a volumetric change that will impact the length of time that another of their jobs will run. They are providing an updated run duration for this job within the same simulation. Let's see what happens when the application team runs this simulation within AAI. To start out, I'm logging into the AAI web UI. Once logged in, I'm presented with the system monitoring page. On this page, I can see the status of all of the schedulers I have connected to this AAI system. To run our simulation, I'll move to the simulation view. As you can see, there are no active simulations at the moment. Let's run our application simulation. In order to run the simulation, I first need to review the scheduler that the simulation will be run in, and the time that I would like the simulation to affect. I'm going to click on the calendar icon, and I'm going to choose tomorrow's date. Once I've selected the date, I'll add the GIL definition of the changes that I'd like to simulate. Once the GIL has been added, I click on the Next icon. At this stage of the simulation, I can choose to select some global state rules. I am going to ask AAI to change any jobs that are in a state of inactive, such as the new job we are adding, to a state of success. I'm also going to ask AAI to treat any jobs that are in a status of failure as a state of success. If I want to add an exception to either of these global state rules, I can do so by clicking on the Add Exceptions icon. I can add the job name or the job name contains string here and the state in this drop-down selection here. Click on Search and confirm with OK. I'm not going to do that as part of this demonstration. Once I'm happy with the global state rules and any exceptions that I wish to apply, I can click on the Finish button. AI will prompt me to advise that the simulation has been successfully submitted. As you can see, the status bar gives an indication of the simulation execution. The simulation has finished. Let's take a look at the result of the simulation. Here I am looking at a monitoring view for the Highport application. I can see within AAI there are two historical executions of the job stream. I can also see that there are two forecasted executions of the job stream. Both are forecasted to run late. As a result of running the simulation, I can also see three job stream executions highlighted in purple. The purple indicates that these entries are simulations. Let's take a look at one of these simulations in a little more detail. I'll open up the Gantt view and I'll expand our window. As you can see, within the box we have made changes. This job has an extended run duration. This is the job for which we were aware of the volumetric increase. We can also see our new job, the simulation. The simulation has added this job for us to be able to visualize. It's also added its dependencies. However, our job stream is simulated and AI is forecasting the job stream to be late. Let's close the view of this particular job stream and open the other simulation that is predicted to be much later. Similarly, I will open the Gantt view and expand our window. This execution illustrates there's even more of a problem. It would appear that this execution of the job stream is going to run over multiple days. Let's have a look at why that might be. Our top level box in AutoSys, if I show the job details, is running every day of the week. Let's have a look at our nested box and see what's happening here. This particular box is scheduled to run Monday, Tuesday, Wednesday, Thursday and Friday. It also has a scheduled start time of 9:30. We could potentially allow the business to bring this job stream home earlier by making some additional changes. We know that the top level box runs on a daily basis. So what happens if we remove the nested days of week and start times from the nested box? we can run another quick simulation and figure that out. Let's jump back into the AAI Web UI. Let's run a new AutoSys simulation. But before we do that, let's clear the simulation data that we currently have. I'll click on the Clear Simulation Data button and I confirm to clear the simulation. Now, I'm going to run a new simulation. Again, I'm going to select tomorrow's date and I'm going to add the same changes. However, I'm going to add a change to remove the date conditions from the box that we identified. Let's click Next, and I'll apply the same global state rules as were applied in the previous execution. And I'll click on Finish. Our simulation has been submitted. And is now complete. Let's take a look at this second simulation. As we can see, we now have simulations of the data in accordance with the changes that we are proposing within the AutoSys environment. Those job streams that were simulated to run late are now, in fact, simulated to run early. This particular forecast and this simulation start on the same day, but note the difference in the predicted end time. The changes that we are proposing in AutoSys will actually result in this job stream being complete the same day as it starts. This is the expected and necessary behavior for the job stream. It's very easy to identify the difference between the forecast and the simulation by the color of the row in the table we're looking at. Let's have a look at the job stream in the Gantt view. Again, I'll expand our view, and we can clearly see now that our job stream will be complete before the deadline. It still contains our additional execution, and it still contains our additional job with its dependencies. In running this simulation, what the business has been able to identify is not only was the proposed AutoSys change going to extend the run of their critical business process to a point where it was going to be delivered late, but they were also able to use AAI to identify a hard start time, an unnecessary hard start time within that application that, when removed, not only made the application run quicker, but it allowed the business to bring the job stream and the SLA back in line with necessary requirements. In fact, the job stream is now running 10% early as opposed to 1% late or only just on time. Thank you for watching.